In this video, we're going to continue working in Minitab with a couple more data sets to practice making more graphical charts. So the first data set that we're going to look at here is, open worksheet from the file menu, and this one is the viscosity data set. So in this data set, we are looking at the viscosity measurements for a chemical product coming out of a production line, you would assume, observed hourly. So it's the viscosity level of a process that makes chemical products, and it's observed hourly. So basically over 40 hours, the viscosity level is recorded here. And we're going to assume that the acceptable viscosity level is 48 plus or minus 2. So basically between 46 to 50 is the acceptable viscosity level, is the acceptable tolerance for the process. And you recorded them. So if you want to evaluate the performance of the process over time with respect to the acceptable tolerance, what kind of chart would you be making? So because this data is collected over time, it's a dynamic data. And one of the first thing to do, or one of the great ways to evaluate this data over time, is to make a time series plot. So here we're looking at time series plot, and we only have one y variable here, and that's the viscosity. So I'm going to select the simple one. So it's asking me for the y variable, which is the measurement, and also it asks me for time scale labels. So in this data, we don't have another variable that is a time variable. I mean, I could have another column here that was basically indicating the time that I measured that, and that will be probably different hours over 40 hours. But that's optional. If you leave that empty, Minitab is going to assume that each one of these are equally separated from each other, and it's going to automatically create a time index on the x-axis of the graph. So let's hit OK here, and here is the time series. So you can see the time index over 40 time indexes, and you see the measurement, the viscosity level. Well, you can quickly catch that the viscosity dropped at about 24-25, hour 25 to an unacceptable viscosity level. Well, before it was at an acceptable level between 46 and 50, but then dropped. So this is a great way to understand the process over time. So time series plot. Another data set that we're going to look at is the last one, which is the CO2. So what we see in this data set is global mean surface air temperature anomaly. And so this is temperature anomaly on the Earth, or actually air temperature anomaly, and the global CO2 concentration for years from 1880 all the way to 2004. So over that time, they recorded temperature anomaly. So the years that had negative temperature anomaly means that that year was colder than an average of those years. And temperature anomaly becomes positive, that means that year was warmer than the average of those years. So that's the anomaly. And CO2 concentration is quite obvious. It's the concentration of CO2 in the atmosphere. So what we're going to create here first is, because the data is over time, it's a dynamic data, what we're going to do is we're going to construct a time series of the anomaly. So very similar to what we just did, time series. This is going to be a simple one where we have a y variable anomaly, and the time scale is the year. So in this case, we have a column for time scale labels. Click OK. And what we see here is the temperature anomaly started at a negative level and gradually increased to the positive level over the years. That's quite a powerful graph to show the rising temperature of the air in the atmosphere. So what we're going to do also is we're going to create a time series of the CO2. So CO2 and time label would be years. And here is the pattern that CO2 concentration increased over time. So you can clearly see the pattern over time. If there is any trend, if there is any seasonality, there could be different types of patterns that you can observe over time. And this is very powerful these days in predictive analytics, where you can where you try to forecast future, predict future based on the historical pattern over time. The first step to make these time series. So in the next step, what we're going to do is we're going to make a scatter plot to show the relationship between temperature anomaly and CO2 concentration. So Scatterplot, here's Scatterplot, is a plot that you graph an x variable across a y variable. So essentially, let me cancel this. Essentially what we're going to do here is this pair is a dot on the graph, where let's say x is the anomaly, x-axis is an anomaly, y-axis is the CO2 concentration. So on that graph, we're going to have this as a dot, this as a dot, this one as a dot, and so forth. So that would be a scatter plot full of dots. So let's make a scatter plot. And it's going to be a single y variable, because we have an x variable and we have a single y variable. So the y variable, we're going to select CO2 concentration, and the x variable, temperature anomaly. And now when you hit OK, you see the relationship between these two. And as you can see, as the temperature anomaly goes up, CO2 concentration goes up, and vice versa. So this shows that there is a positive correlation between these two random variables, temperature anomaly and CO2. And here you see some basic statistics on these two random variables. Well, this shows the correlation between these two. Well, not necessarily showing us a causation, it's a correlation, but we know as a fact that rising temperature has been caused by CO2 concentration. It just happens to be true. But in this case, this is only showing us the relationship between these two random variables. So that was an overview on time series and scatterplot that we did on these couple of data sets. Thank you for watching.